Okay, and so let's just jump in then with some evaluation, right? So evaluating a function, that means we're going to be taking, other inputs besides just x here. So again, the way this is written, this is, the function f applied to the variable x, and it results in this right here. It takes that x and squares it, and then subtracts 3 times that x, and then adds 2, right? So we could just as easily put like a f of, kind of like a blank here if we wanted to, and say that would be then, that blank squared minus 3 times that blank, right, plus 2. Right, that's another alternative there. We can put any input we want. Typically we put, variables in those blanks sometimes. Sometimes we put, most of the time we put numbers in those blanks. And then sometimes we also put like expressions in those blanks too. So let's just say our directions here are to evaluate. Okay, and then simplify, I guess, kind of thing. So for example, again, not doing anything too crazy here. F of 3. Okay, f of 3. So, we want to just take that 3, right? It's replacing the x in the original function here. That's the only, f function we have defined. So the x is replaced by the 3, and so that means in the other places, right, the 3 will replace the x as well. And then we just simplify. So 3 squared is 9, minus 9 is 0, plus 2 is 2. Okay, you do want to follow correct order of operations there. Okay. So, parentheses first. Well, there's nothing in the parentheses to do. Exponents, so the 3 squared, it gives you 9. And then multiplication division, so I give you the 3 times the 3 there, which is 9 as well. And then you do addition, subtraction. Well, multiplication division you do from left to right, and then addition, subtraction you kind of do from left to right as well. Okay. So, there it is. All right. We can see other things too. For example, I could write something down like, okay, now that we know that f of 3 is 2, I could also write something like 3 f of 3. 3 times f of 3, what would we know that is going to equal? 6, right? It's got to be, right? If we just figured out that f of 3 is 2, then we can replace that f of 3 with a 2. It's really just 2. So it's 3 times 2, which is then just 6. Okay? So stuff like that too. Okay. Once you know the value of that function, you can then do other things with it too. All right, take 2 seconds here and go ahead and just evaluate what f of -1 would be. That's out of 6, so you got them all right. All right, f of -1. Let's see here. Let's go to Morgan. Morgan, you got an answer for us here?
No, I don't know.
Okay, that's fine. Go to somebody else here then. Gotcha. How about Lindsay? You got an answer for us?
Still working on it.
Okay, no problem. I'm going too fast. I'll slow down. I'll wait.
I think it's 4.
You got 4? Okay, so let's see here. So what did you do? We plugged the -1 in for the x. Okay, just like that. Okay, so -1 squared is going to be what? Oh my gosh. Thank you. -1 squared is going to be what? Oh, go ahead, Lindsay.
I wrote it down wrong. I wrote it as cube.
Ah, okay, there we go, yeah. All right, well, let's just do it this way then. So -1 squared would be +1, right? And then we have the -3 times -1, so we plus 3, and we have plus 2, and so those will add up to make just a 6 there. Okay, so you should get 6. You should get 6. Sorry, I'll give you guys some more time next time. Okay? All right, let's try another one here. So of course, we can plug in numbers, we can plug in different variables if we want to, and like I said, we can plug in expressions. So we can also evaluate things like f evaluated at 2x. 2x. So that means instead of you know, these x's, right, for f of x, the function applied to x, took that x and squared it, subtracted 3 times that x, and then added 2. So here with our blanks, right, we're replacing the blank as a 2x. So that means it's going to be 2x, that quantity, right, squared, minus 3 times that same 2x, and then plus 2. Okay. And since we, you know, can simplify this some more, we should try and simplify it some more. Okay. So that 2x quantity squared, well, remember that's 2x times 2x, so we end up with 4x squared. Both the 2 and the x get squared there. And then minus 6x, and then plus 2. Okay. If you want to factor out a GCF there of 2, you can. You know, it's not necessary, I would say. I don't know if that factors or not. But again, it's not necessary to factor it right now. We're just like kind of evaluating, simplifying, combining like terms and stuff like that. Okay. So at this point, you could be done right here. Okay. All right. And then here's one for you guys to try. So you all try this one here. I want you to find f of 2 plus f of x minus 3. Okay. So go ahead and evaluate f of 2 plus f of x minus 3 there. Let's give that one a try. F of 2 plus f of x plus f of 2 plus f of x. Together because that 2 is like inside the function, so you have to actually evaluate this first and then add it to this evaluation. We can't combine those off right off the bat. So not because they're going to where is your f2? Where do you evaluate? Like it looks like you did. Oh, I see. So we can't combine these two because we have to evaluate them both separately. So leave it f of 2 and then add g f of x. I understand that.
Yeah.
Good. Okay. Yeah, be careful when you square that out. It should be x minus 3 times x minus 3. So it's below that. Multiply that, right? You can't distribute that square over. Question. The positive square? I think this should be. So that'll be a positive 9 and then another plus 9 and that plus 2. Cool. Good. Good. And you combine those two numbers, right, together? Okay, so this is when, where did you get the part that you need? Oh, okay, x minus 3 squared. When you square a quantity like that, that means x minus 3 times x minus 3. So we have to then FOIL that out. Okay? Yeah, good. That is not what I got. Good. Good job, Brian. Sorry. I got that. So yes, so this is correct. F of 2 would be that. Oh, you wrote the function down as a plus -3, right? Yeah. And so then I think you forgot that it was -3 because it was -3x and then a positive line. So that should be there. So that's where you went. Okay, pretty good. Let's see here. Alright, so this f2 is this f2 right here. So what is 2 times 2? Oh no, so we're just evaluating f of 2 now, so we're going back to the original function. All you gotta do is replace that with a 2. That's it. And then same idea here. You're just gonna replace all these x with an x minus 3 and then multiply it out and stuff like that. Okay. Good. All right. Good. Saw a repeated error here that I want to talk about. I tried to address it to all of you. Sorry if I didn't get to some of you. Okay, there. But there's our answer. Okay, x squared minus 9x plus 20. Okay, so in evaluating these, a couple things I want to say. First off, right, the f of 2 plus f of x minus 3. As these are written, we cannot kind of like combine anything in here, okay? So for example, we cannot necessarily say that this is equal to f of x minus 1, for example, okay? Which is if we combine like the 2 and the x minus 3 together, okay? We cannot say that's true, so I'm going to put a not equal to, not necessarily equal to, the same thing there, okay? Instead, we have to kind of evaluate these things separately. First, we evaluate that f of 2, then we evaluate that f of x minus 3, and then we're going to combine the two answers together. Okay. In the evaluation process, I think most people were okay with evaluating the f of 2 piece, but evaluating that f of x minus 3, and I kind of wrote, this is written on this way on purpose, that x minus 3, when it's being squared, okay, you have to go back to what really the basic definition of what it means to square something. What does it mean when you square something? You're doing what? Multiplying it by itself. Exactly right. And so when you see that x minus 3 quantity squared, okay, the temptation is to like distribute that and just make it x squared minus 3 squared, like that. Alright? But that would leave x squared minus 9. If we follow back on our basic definition of what it means to square something, if you take that x minus 3 and multiply it by itself, well then we get x squared minus 6x plus 9. And you can see then these two things aren't equal. So in general, as you cannot distribute a square over subtraction or addition, right? Now, if this were x times 3, if it was x times 3 quantity squared, then absolutely, that would be equal to x squared times 3 squared, okay? But since it's x minus 3, the square like that does not distribute like how we want it to, okay? You can just see it right here, okay? X minus 3 squared, if you kind of distribute it, you get x squared minus 9, okay? But in fact, it should be this, the x squared minus 6x plus 9, and these are not equal, okay? So, any questions on letter D there? All right. So while, functions and stuff like that may be very familiar to us, right, it does bring up some interesting, potentials for mistakes. So that's why I wanted to make sure we review that kind of stuff too. All right. So now we're going to look at some special kind of functions. All right. One such special function that's going to show up, especially should you choose to continue your mathematical career, beyond pre-calculus, especially into calculus, you will see both of these two things showing up in different kind of aspects. So the first one here is the piecewise or compound function. Okay, piecewise or compound function. Okay, and these can be, I guess, intimidating or scary, or just because they're different, we're kind of like, uncertain, we're less sure about ourselves, but really they're not that, crazy. Of course, that's not fair. I'm a math teacher, but I mean, really, Anyway, so our function here, we're going to define it, but the function is going to be defined as two different pieces. So we're going to say it's going to be equal to x squared plus 1, and it's going to be equal to 3x minus 1. Okay. Now the problem is, right now, if I were to graph this function, I would be graphing the x squared plus 1 and the 3x minus 1 simultaneously. So, let's see if I do that. X squared plus 1, x squared plus 1, 3x minus 1. Okay. And if I graph those two things simultaneously, okay, you can see I get a parabola and a line, which is no surprises there, but it doesn't pass the vertical line test, right? It fails it, okay? I mean, I could draw a vertical line anywhere right in here, and it's going to hit that graph of my function, more than once, right? Because I have two graphs that are kind of overlapping there. So it's not really a function right now, but that's because we still have some more stuff to do here, right? Typically, you have a piecewise function, and the certain pieces apply for certain values of x. So here we'll say that x squared plus 1 is going to apply for x values less than 0. And here we will say that 3x minus 1 applies for x values greater than or equal to 0. Okay. And so now when it comes to, evaluating these, okay, let's say we wanted to evaluate, and again, these will be some examples here. Let's say we wanted to evaluate f of 6. Okay. I am not going to take that 6 and plug it into both pieces of my piecewise function. By the way, piecewise functions don't necessarily have to have only two pieces, right? You can have 3, 4, 5, 6, 7, however many pieces you want to a piecewise function, or how many pieces you don't want, I guess, anyway. So if we want to evaluate f of 6, there's only one of these two functions that we're going to plug it, to where we will plug it in. Which one of the two functions does that 6 get plugged into? Devin? The second one. Okay, so the bottom one. How did you know?
Because it is greater than or equal to 0.
Yes, 6, right? The value we're evaluating here, the x value, okay, it's a value that's greater than or equal to 0. So we're going to plug it into this bottom one, so it's just going to be 3 times 6 minus 1. Okay. F evaluated at 6 uses the bottom function, and so that's going to be 18 minus 1, then 17. Okay, that's right. Let's try another one here. How about f of negative 3? Anybody? Top or bottom? Goes to the bottom? Ooh. Top. That's right. Okay, negative 3 is less than 0. So it'll be negative 3 squared plus 1. Please also be careful when you're typing things in your calculator. I'm going to say this now, and it might happen later. I don't know. And I know you might not, you might even be trying to type this into your calculator, but anyway, if you type -3 squared plus 1 in your calculator, right, we all know what this answer is, right? -3 squared is positive 9, plus 1 is 10. But when you type into your calculator like this, your calculator gives you the wrong answer. It gives you -8, okay? And the reason why your calculator gives you the wrong answer is because your calculator is programmed, you know, and it only can follow the rules that it knows. And so when your calculator sees this typed in like that, okay, your calculator is actually following order operations as it's been programmed. So it's going to do the exponent, 3 squared, then multiply by that negative to make it then, so 3 squared is 9, multiplied by the negative is now negative 9, and then add 1, you get the -8. To fix this, you have to put parentheses around around that -3, like you would normally for a substitution anyway, to then show the calculator, no, I want that 3 to be negative first, then we square it and add 1, and then you get the correct answer of 10. So please be careful when you're like squaring or, you know, doing any exponents with negative numbers. Put parentheses around those negative numbers. Okay. Anywho, 10 is the answer. Okay. All right, I'm going to have you guys try 2 here. So let's have you do f of -3/5. Fractions, Mr. Widmeyer. I hate fractions. And f of 0, please. Okay, so go ahead and evaluate f of -3/5 and f of 0, please. Try doing it without a calculator first, and then check your answer with a calculator, especially if you don't like fractions. Okay, try it out first, and then check your answer. I'm going to build some confidence. Okay. To add these two things together, right? Can we add them as different? Right, but can you add them that way too? 1/1 is the same thing as 25/25. And so when you add 9/25 to 25/25, you need a common denominator. In other words, what I'm trying to say is you need a common denominator. Good. Think of it as like dividing like terms. Oh, sorry, okay, good, yeah, sorry, good. Yep. You got it? You're not sure? Okay. So, -3. Which one's going to be plugged into? Well, so for x values less than 0. Yeah, sorry, yeah, we're using this function again. Okay, that's, yeah, plug that for the x value. So it's going to be that squared and plus 1 again. That one goes for x value. Sorry, we are doing that piecewise function. are. Here we go. Should have gotten 34/25 and -1. Okay? So there it is, piecewise functions. You can actually graph piecewise functions on your graphing calculator. Okay? If you're interested here, I'll show you. And this is something that we won't, actually we'll be looking at the graph of piecewise functions in a little bit here, so why not? It can't hurt to introduce this right now. So again, here's our piecewise function that we want to graph. I already have both of those functions in my graphing calculator written. The one additional thing that we need to do there's a couple additional things we need to do. First thing we want to do is actually put both of these functions in parentheses. So, those of you that are familiar with the calculator, you may not know this. Maybe you do, I don't know. So second delete, if you press second and delete, it changes the cursor there. You see, it's not this like underline thing that like flashes and stuff like that. And that allows you to insert stuff in front of things without deleting or overwriting. So in other words, if I now press the parenthesis button, it inserts parenthesis in front without like overwriting the x squared and making you rewrite everything else. Okay, so I don't know if you knew that was a thing, and then we can go over and put parenthesis in here. Same thing. So again, you're going to go like wherever you want to insert something. So here I want to insert something in front of the 3. So I'm going to highlight the 3, press second delete, and that allows me to type all sorts of stuff. I can type a bunch of things in front of that 3 if I wanted to. Of course, don't want all that junk, so I'll get rid of that back to the 3, and then parentheses on that. Okay. So we have those two things in parentheses, and then we will also now put in these inequalities here, x less than 0 and x greater than or equal to 0. We're going to divide, and then open a parenthesis, and we're going to divide by that inequality, x less than 0. So we're going to press x again. The less than symbol is in second math, which is to the test menu, and you can see there's all of our inequality symbols right there. And so we want less than, and then 0. Okay, so hopefully you can see that now. There it is, x squared plus 1, that quantity divided by x less than 0. And then the second one is going to be x, and again, second math, to go to the test menu, greater than or equal to 0. Okay, so there it is. We've just taken our pieces of our piecewise function and divided by their kind of restrictions. X less than 0 for the x squared plus 1, x greater than or equal to 0 for the 0. Okay, and we graph it. And so you graphs half the parabola there, and then it graphs the line right there. And I can zoom it just a little bit just so you can see how it jumps. Okay, so there it is, piecewise function. And now you can see, yes, it is a function, right? Even at 0, because the top piece does not include the x value of 0, but the bottom piece does include the x value of 0. So that's when we have a jump there. Okay, piecewise functions. And the way that works, for those of you that are, maybe like a little programming minded, or you like looked at programming before, right? The x less than 0, this command, all that does is it returns a 1 if x is less than 0. Like that's whenever x is less than 0, it returns a 1 for like that's a true statement. But then for any x values that are equal to 0 or greater than 0, it will return a 0, which then makes this thing undefined, and so it doesn't graph anymore. And the same thing for that. Right? This thing, the x greater than or equal to 0, will return a 1 whenever x values are greater than or equal to 0. It returns a 0 otherwise, and so it won't graph the piece. Makes it undefined. Okay? So that's how that works. And it gives you a nice little graph of piecewise function there. Anywho, piecewise functions, that was that. Alright, we'll come back and look at some graphs of those later, how to graph them and stuff. Right now I want to look at one other very special function, okay? And that is the difference quotient. Okay. And the difference quotient, okay, is taking your function, evaluated at x plus h, then subtracting the original function f of x, then dividing that difference by the variable h. So yes, there are two variables kind of happening here. You have the variable x and the variable h. So you first evaluate the function at x plus h, then subtract the function evaluated at x, and divide that whole quantity by h. And one little stipulation here, we don't want h equal to 0, because that, of course, would make us, well, actually not undefined, it would be indeterminate form. You'd have 0 over 0 there. Okay. This, believe it or not, this little difference quotient here, okay, attached to a limit, is fundamental to about half of the calculus that you'll be learning should you, again, proceed on to like Calc 1 or Calc 1 and Calc 2. Okay. This little thing right here is fundamental to half that calculus. Okay. So, or one of the major branches of calculus, I guess. So anyway, so let's like actually do it and apply it to something. So let's apply the difference quotient to f of x equals 2x plus 3. Okay. So if you look here, to evaluate the difference quotient, well, we need to first figure out what f of x plus h is. And then we'll subtract f of x. We already know what f of x is. There it is. It's 2x plus 3. So let's try and evaluate what f of x plus h will be. I'll just do that work like right here. Okay, because we need to know what that f of x plus h is. Okay, so since f of x, f, the function applied to x, gives us 2 times that x plus 3, f applied to x plus h is going to be 2 times the quantity x plus h, and then plus 3. Just like if we evaluated f of 3 or f of 4, you know, whatever it is, you take that thing that's inside the parentheses there and you substitute it in place of the x. So here the x is x plus h, so this x becomes x plus h there. And so now we can rewrite our difference quotient using these two pieces. So we'll start with the f of x plus h piece, which is 2 times parentheses x plus h minus 3. Okay. And then minus the function f of x, and we need to put this in parentheses here, 2x plus 3. So make sure you put the f of x there in parentheses. So there is the f of x plus h piece. There is the f of x piece. And then we'll divide that whole quantity there by h. Okay. And again, the difference quotient, you know, what's the there is actual like meaning behind it. It's not just some like random thing that's just like, here, this is a thing that we do. It actually has more meaning behind it, but we'll get to that later, not right now. Okay. We'll get to that, what that means later. Right now, we'll just have a name for it. And again, mathematicians being not very creative, we call it the difference quotient because there's a difference and there's a quotient. Okay, so not very exciting, right? Anyway, let's simplify here. So that 2 can distribute to the x and the h. So we have 2x plus 2h, then minus the 3. And then the minus also needs to distribute. So the 2x and the 3 there. So it's minus 2x minus 3, and then all over h. Like that. Okay. And now that we've kind of distributed in our numerator there, is there anything that we can simplify in that numerator? Yeah, so the 2x cancels out with the minus 2x there. Okay, whoops, I put 2x plus h minus 3. That's supposed to be a plus 3, right, according to what I had written right there. I made a mistake. I apologize. And so that should be a plus 3 as well. So yeah, the plus 3 and the minus 3 should also cancel. They will, if I write it down correctly in the first place. Okay, and so what's all that's left in the numerator then? Yeah, 2h. 2h is left in the numerator, and then h in the denominator. But now what can we do? We can cancel the h's out, right? H divided by h, they simplify to just 1, and so we're left with 2. Okay. So all that work, all that mess, and we simplify down to just 2. And again, with meaning, with context here, this would actually make a lot of sense that we simplify down to 2. All right. Right now, you might be like, what? Why? And that's it. Okay, but it is 2. It simplifies down to 2 there. Questions on anything so far? All right. So let's do one more of those just to make sure we're feeling comfortable. And again, I'll kind of help us out because these are not the easiest. And then we'll look at our graphs. Okay. Oops, I don't know why I'm choosing that here. All right. So again, I'll rewrite the difference quotient here. F of x plus h minus f of x all over h. Okay? And we want to apply the difference quotient to g of x equal to x squared plus 2x minus 6. We're we're going to apply the difference quotient to g of x equal to x squared plus 2x minus 6. So I know the difference quotient here, it says f of x plus h minus f of x all over h, but the same can be applied to g of x here. So just instead of f of x, we now have a g of x. That's all. It's just the function name has changed, but it's the same idea. So we already have our function here that we're going to subtract. We need to come up with then what that f of x plus h is. So again, I'm going to do that as a little side work here. So I'll find what g of x plus h is. And so instead of x squared, it's going to be x plus h quantity squared. Instead of 2 times x, it'll be 2 times that x plus h, and then minus 6. So again, just substitutions. Anywhere there was an x, now there's an x plus h, the quantity. And then to square this out, well again, x plus h quantity squared, that is not x squared plus h squared, right? We have to actually FOIL this out. So I'm going to write it out, like this, so it's very obvious what we need to do now, right? X plus h squared is x plus h times x plus h. I'll go ahead and distribute the 2 here, so we have 2x plus 2h, and then minus the 6, right? 2x and 2h there. And so, oh my gosh, let's see here. So x times x is x squared. X times h, xh. H times x, hx, or also xh. So we're going to have 2xh for our middle term, and then h times h is h squared. Okay, plus 2x plus 2h minus 6. Okay. Question on anything? No? Okay. Now, if you look, there's no like terms to combine, so this entire thing here, okay, is going to go in for that f of x plus h. So I'm going to rewrite it, over here, x squared plus 2xh plus h squared plus 2x plus 2h minus 6. So this entire thing here is that f of x plus h. And then we will subtract g of x. Or, sorry, I guess it's really g of x plus h. They're not f of x plus h. And then we'll subtract g of x, which is just the x squared plus 2x minus 6. Okay. All over h. There are all the pieces put together into that difference quotient. So this one's kind of funky too. I think it's like a different kind of substitution because you first have to figure out what g of x and g of x plus h are, and then you substitute those two things back into that difference quotient. So it's a lot of substitutions going on there. All right, we'll distribute that minus sign. So I'm going to rewrite this one more time. Okay. So it's minus x squared minus 2x plus 6. Don't worry, you don't do this for all of calculus either. You learn shortcuts and stuff like that. But when you start out, you do these. Okay, so again, I just distribute the minus sign there to the x squared, the 2x, and the plus 6. Okay, and now at this point, things should cancel out. So, does anyone see? What can we cancel here? What can we cancel here? Yeah, so the x squared cancels out with the minus x squared. We have a positive 2x here that cancels out with this minus 2x. And then this minus 6 cancels out with a plus 6. And so then what remains? Well, we have a 2xh. We have an h squared and a 2h. And that's all over h. Can we simplify any further? Yes. So if we factor an h out of the numerator here, right, each one of the terms has at least an h. So we'll factor the h out, leave behind then a 2x from here, an h from here, a 2 from here, all over that h. And then those h's can cancel. And whew, we're finally left with 2x plus h plus 2. And that's as far as we can go. Fun. Fun, fun, fun. questions on any of that? Okay, this is not going to go away, and most likely it will be on, there will be a question like this on our test, okay? So, you know, if you are concerned about this question, don't worry, we have plenty of time to practice it, right? I can easily come up with, you know, a ton of these different, you know, ways to do, or different problems for this, so don't fret too much there, okay? Go ahead and put that away then, and let's get out a piece of graph paper, and we're going to look at graphing some piecewise functions. And I know we're running short on time here. I apologize. That lockdown drill kind of slowed things down for us there. Okay. Abby, would you actually mind grabbing me a piece of graph paper for myself? Thank you. Thank you. Okay. So, like I said, we'll now kind of take a little bit of a break from that crazy difference quotient stuff, and we'll do some drawing. All right, so graphing piecewise functions. We'll just get some practice here. All right, and let's start with the piecewise function. So I'll say we got f of x, and let's define that to be equal to 2x minus 1 for x values that are less than or equal to 1, and then we'll define it to be negative 3x plus 4 for x values that are greater than 1. Okay. All right, and so let's draw some x's in here. All right, and so what I recommend for graphing these piecewise functions, and again, you can do it, I guess, different ways and stuff like that, but I recommend just taking it like a piece at a time. All right, and so let's just start with this top piece here, the 2x minus 1, and we want to only graph that 2x minus 1 for x values that are less than or equal to 1. So what I like to do is to start at, you know, that point where we kind of transition, right? So we can see at 2x, at the x value of 1, we switch from, you know, this top one then down to the bottom one, right? So let's go ahead and just plug 1 into our function here. So it's going to be, you know, 2 times 1, which is 2. I'll go ahead and just do it this way. 2 times 1 minus 1, and so we get 1, right? So we have the point, 1 for the x value, 1 for the y value. And so we'll plot that point. So let's see, 1, 1, that's going to be right here. Now, because x can equal 1, that means I can draw a solid dot there, right? Because that is a point that is going to be part of our graph there. So a solid dot. And then at this point, we can continue to graph this piece using a variety of methods. I mean, one method is you could just pick other x values that are less than or equal to 1. So like, what would be another good x value that we could pick that's less than or equal to 1? Yeah, sure, 0, right? So you can plug 0 in here. 2 times 0, 0, minus 1 is negative 1. And so we have the point 0, negative 1. Okay? At this point, we now have, you know, kind of 2 dots. We could draw it because it's just going to be a line, but we can keep going. Another way you could use it is, well, this is in slope-intercept form, right? 2x minus 1. In fact, there's that y-intercept of 1. We could use the slope to get more points. Of course, you know, from here, we're not going to go up to right 1 anymore because at 1, you know, we don't want to go any further than x values of 1 because of that, you know, constraint there. So instead of going to the right, we'll go down to left 1, down to left 1 and put a point, down to left 1 and put a point, so on and so forth. And then we can just kind of, you know, connect the dots there and make our line. Again, only drawing to the left because we're only interested in this piece of our function for x values that are less than or equal to 1. Okay? And then we'll do the next one here, negative 3x plus 4. All right, so for this one, again, I'm going to start it at 1. Even though x can't equal 1 here, I still want to try it out and see what we get. So negative 3 times 1 plus 4. So negative 3 times 1 is negative 3, plus 4 is going to be 1. So again, we get the point 1, 1. Except at the point 1, 1, when we go to graph this piece, we're going to use an open circle because we don't equal 1 here, so we're not equal to 1. So at 1, 1, we're going to graph an open circle here, which they join up, so that's kind of cool. Okay, they actually like join up, meet up here. And then again, from this point, you can choose. You can, plug in other x values that are now greater than 1. So for example, we could plug in 2. 2 is greater than 1. So negative 3 times 2 is negative 6. Negative 6 plus 4 is negative 2. So it would be the point 2, negative 2. So we have this point now. You can plug in, 3 if you want to. 3 times negative 3 is negative 9. Plus 4 would be negative 5. So 3, negative 1, 2, 3, 4, 5. You can also use the slope. Down 3, right 1. Down 3, right 1, right? And so there's that. And again, we can just now connect the dots. So there's your piecewise function. Okay. There are our pieces. I want to do one more here. I think I should have enough time. Sorry for it being so close to the bell, guys. All right. Question? Yeah, you gotta go. All right. All right. G of x. Let's look at this one. This one will make it 3 pieces. So we'll say it's going to be 3x. It's going to be x squared plus 1, and it's going to be 4. Okay. We'll have it be 3x for x values that are negative 2, less than or equal to x, less than or equal to 0. We'll have it be x squared for plus 1 for x values 0, less than x, less than 2. And we'll have it be x, it will be at 4 when x is greater than or equal to 2. Okay, so 3 different pieces here. So we have 3 little pieces of the graph to graph. So let's see, I'll draw some axes in. The homework will be on Google Classroom. Okay, Alyssa, if you want to just... Yes, I can do that, no problem. All right. So there are axes. We'll get this done here. So now if you look, 3x, right, we have a starting and a stopping point. Right? Here in the original, actually the first one we did, 2x minus 1, it was just all x values less than or equal to 1. But now that 3x is only true for x values between negative 2 and 0. So again, I'd recommend you do the endpoints. Okay, so do the endpoints. So let's plug in negative 2 here. 3 times negative 2 will be negative 6. So we're going to have the x-coordinate negative 2 and the y-coordinate negative 6. So negative 2, negative 1, 2, 3, 4, 5, 6. And we'll put a solid dot there because, again, our x value can equal the negative 2. And then that goes to 0. X value is 0, so 0 plugged in is 3 times 0. It's going to be 0. So we have the point, again, a solid dot at 0. And since it's 3x, we know it's going to be a straight line, so we can go ahead and just like connect those 2 dots there, like so. Okay, so we kind of took care of that first piece there, the starting point and stopping point. Let's do the same thing for the second part, x squared plus 1. We'll plug in that 0. Okay, plug in the 0 here. 0 squared is 0, plus 1 is 1. So at the point 0, 1, though, because we're not equaling the 0, we're going to put an open circle at that 0, 1. Okay, because we're not including that point, but it's something we want to kind of start from. Then we'll plug in the 2. 2 squared is 4, plus 1 is 5, so at 2 we'll go up to 1, 2, 3, 4, 5. Okay, now this graph is going to be part of a parabola, so there should be some curve to it. If you want to, there's x value of 1 here that we didn't evaluate. I'll go ahead and do that. 1 squared is 1, plus 1 is 2, so we have the point 1, 2. And so we can kind of like curve it out like that. Okay, and then last but not least, for x values greater than or equal to 2, we're going to just have a y value of 4. So we have the point 2, 1, 2, 3, 4, and then every x value after that is just going to have a y value of 4. So it'll be a nice horizontal line on out like that. And there's our piecewise function. Okay. Questions on any of that? I know that was a lot. Thank you guys. Let me give you the assignment here. It'll also be on the Google Classroom too. If you just want to look it up there, that's fine. Your homework is page 49, numbers 37 to 52, but only do every third problem. Okay, so like 37, then 40, then 43, then 46, so on and so forth. Okay, I also want you to do 94, 103, and 106. And for 94, please make sure that you use a calculator. Okay, please make sure you use a calculator on number 94. Okay. Sure can. Yes.
Can you send me